Hello viewers, in this video we are going to talk about the finding RMS of a waveform, and we have a waveform here, so you should consider the waveform below and we should determine the average and also the effective value of this waveform. So from here we can see that this waveform looks like a trapezium and an inverted right angle triangle. By a trapezium we can cut a right angle triangle and we get a rectangle here. So from here we move straight to finding the average. Now what will be the period? To find the period, it is where the waveform is starting and where it will begin again. You can see that this waveform that we are having is starting from 2 here and it's going to begin from what? 12. Once it begins at 12, you subtract 12 minus 2 and you get the period to be 10. So that's how you find the period. Or you can say that it will start from 0, then it will also come and start from 10. Starting from 0 to move this way, this way, this way, then it also starts from 10. So still the period is 10 seconds. Now average is always equal to the area of a cycle divided by the period. So this cycle, you have to find the area of this cycle, and these cycles are definite shapes and you can find the area from their dimensions. So we have A, B and C, where A is a right angle triangle, B is a rectangle, and C is also an inverted right angle triangle. So to find the area of the A part, is half base times height, half times the base, which is from 2 to 4, that is 2, times the height, which is 10. That will give us 10. For the rectangle part is LB, that is 4. From 4 to 8, we get 4 as a base, and the height is still 10. So we get 4 times 10, 40. For the C part, since it has inverted, our height is now negative 10. So we get negative 10 multiplied by 2, multiplied by half, we get negative 10. We add all our area and we get 10 plus 40 minus 10, that will give us 40. Our period is 10 seconds. Finally, our average becomes 40 over 10, that is 4 volts. Now let's move straight to the effective value. To find the effective value, that's the B part, you have to square the cycle to find the area under the square cycle. Once you square the cycle, this inverted part will move up because there wouldn't be any negative. So it will look somehow like this. But once you have this, you have to find the area under the square cycle. And once you square it, you know that you are going to get the VM, that is the peak voltage, to be 100 because it has been squared. So from here, you are going to find the area under the square cycle once again. The rectangle is LB and the height is now 100, not 10, because it has been squared by 4. The 4 is still the base, that is from 4 to 8. So we get 400 here. But for the right angle triangle, for my previous video, you can observe that the area under the squared cycle of a right angle triangle is always a squared b on 3, the height squared times the base on 3. So you have to subscribe and also follow my previous videos so that you get more understanding. So from here you are going to get the a squared, which is 100 times the base, which is 2. The base of the right angle triangle is from 4 to 2, so it's 2. So from here we get 203. But we are having two right angle triangles here, so you multiply that by 2, you get 403. Our total area becomes 400 plus 403. We get 1603. Then we divide it by our period. So when you divide it by 10, you get 160 on 3. Then finally we take square root of the whole result. Then we get 7.3 volts. Thank you for watching my video. Kindly subscribe and follow as I put more videos similar to this.